Hello everyone, a very good afternoon to all of you. I am Priyanshi, welcoming you all on behalf of Solar Quarter and First Group to our webinar on latest advancements in solar tracker technologies Thailand. Thank you attendees for joining us today. I hope you all had a great time in networking with your peers in the exhibition tables. Let me briefly take you to the overview of today's event. Solar technology is currently the fastest growing generation of technology, and substantial investments are poured into technology development due to the rise in demand in the solar sector. The foundations or structures on which the whole solar project rests are increasingly becoming important, and changes in design and material are happening globally as well as domestically. Solar trackers significantly boost the amount of electricity through the constant orientation of PV panels towards the sun for the whole day. This webinar will discuss the latest technology advancements, minimum qualifying criteria and selection, most suitable types as per local solar market, and cost trends for solar trackers for both rooftop and utility solar. Now, I take the pleasure to thank our sponsor Arctech for extending their immense support to organize this event. We'll be playing a sponsor video of our exclusive partner Arctech, requesting my team to play the video.
Priyanshi, you're on mute. Sorry.
Thank you for informing me, sir. So we'll be starting our session with
Plab, can you see me okay?
Yeah, hi. Thank you for playing the video. And my colleague Priyanshi might have some technical issue. So we'll start today's session with a presentation from our sponsors. And for that, we have Mr. Yango, Global Product Marketing Manager, Arctech. Welcome on screen, sir.
All right, thank you very much, Palat. Yeah, I'll just probably quickly start my presentation here. Let me do a screen share. All right, I trust everyone can see my screen, right?
Yes, sir.
Okay, cool. Thanks. So, before doing the presentation, just a very, very quick introduction of myself. I'm the product marketing manager of Arctech Solar. So, I'm the person who would deliver the value of our technology and the products and to the markets. And today, the topic will be the latest advancements in solar tracker technologies. And this is a special one for Thailand market. All right, let's not waste time. So first, I would like to have a very quick snapshot of Arctech Solar. So we are a solar tracker, actually solar racking and tracker manufacturer in the world. And in Asian Pacific, we have like a very strong market status. Yeah, we've been list like number one solar tracker supplier in APAC region for a sequential of like 4 or 5 years. And as you can see that globally, we have deployed over 40 gigawatts of different type of rackings. Although tracker is our core business, but around solar tracker, we have also developed many different technologies for to support this type of development. For example, we have our own like a wing lab. I think Arctech is the only solar PV company in the world who own its like wing lab. And later on, we will tell our clients, like our audience, what a wing lab is used for. Okay. Before we start the next part, I normally would like to do like a little exercise here with our audience. So, what is a solar tracker like in your mind? I believe in most people, it would be look like this. So first, it's like a solar racking. You need some posts, right? Some posts, and as a tracker, there should be one torque tube, and there is must be like a little motor in the middle. This is like a motor, and then we put like a solar panels on both sides of the motor. So it's like one motor in the middle and two wings. So that would be a solar tracker look like in most people's mind, I believe. So here it's like a better drawing. This type of design, you will have one fixed point in the middle, like the motor. If the motor is not moving, it will be like a little lock, like this. Yeah, and both ends are free, so it's easy to get like a deflation, like this, get twisted. So for this type of this design, you normally would need like dampers or springs to stabilize the structure. But this is something we would have to say it's kind of outdated these days. So in order to tell what's the advancement about the solar tracking technologies, we will have to look back a little bit. So this is like a very general roadmap of solar tracker technology. So before 2010, there are many different early technologies. I believe before 2010, there was like barely the solar industry market. Yeah. So many people, many like companies, they're trying different thing. And then in 2010s, the linked row trackers, they become like a dominance. They've developed like a very good products. And then led by a new company, another company who start to use the single row, single access tracker. So that has dominated the time until 2020. So today you can see like many company there have like a very mature products on this type of tracker, but even these single point drive tracker uh, cannot match what is needed for the current status. So that's why we should need like a new structure. It's called a synchronous multi-drive tracker. So this tracker is believed to be more stable, stronger to the current industry. What is that? Let's look at the background a little bit. So I believe many of you should be more familiar with the solar PV module development. So especially in the past 3-4 years, solar PV module has become really, really big. Yeah, we've seen PV modules growing from 400 watts to now close to 700 watts. But you know that the efficiency of PV cell hasn't changed much. It could maybe increase from 18% to now maybe 22%. But the solar wattage, the wattage of the PV module has come up so quick. That is because these people, these manufacturer, they increase the size of the PV module. So PV module used to be 1 meter by 2 meters by 1 meter in size. Nowadays, it could be like 2.4, 2.3 times 1.1 or 1.3. Very, very massive. And because of that, the tracker needs to be longer or wider or even taller. So if we didn't do anything about solar tracker design, let's say use the same traditional design with only one fixed points, or you can say one motor in the middle, the tracker will be very fragile, especially on both ends. So the problem is like the easiest a risk will be the deflation, and like this, you can see that. So the both ends are quite weak, and it will be very, very unstable. So in order to understand solar tracker development, how do we design solar tracker? We will have to do some wind tunnel test to understand the behavior of the tracker design. So here is like a sample of how the little model look like in a wind tunnel. So we developed our product like protocol and put them into this a wind tunnel. And within this wind tunnel, all this little model, they are put on the plate, and this plate can rotate it. So we can simulate the wind from any direction. Okay, let's look at this chart. Yeah, I can explain a little bit further. So these charts is the result from a wind tunnel test over a traditional solar tracker design. So if we look at this dot, for example, what does it mean? It means I put my solar tracker at a steep angle of like 45 degree and get the wind blow from this side. So we call nose up, like this point is like a up. We call this nose up towards the wind direction. And then we increase the wind speed in the wind tunnel. And once the wind speed reach this point, the tracker, the little protocol, will get so deflated, it gets so twisted, it's twisted over 32 degree. And in reality, we believe that tracker, that kind of design, will fail in the real environment. And then we do a second test, maybe from another orientation, and the deflation or the damage happened right here. And then we test the same, like this thing over and over again at different timing, different orientation, different tilt angle, and we got all those dots. And then you will find that all these dots, all these failure points, they are above a certain line. So which we draw here, the dark line. So this line represent the critical wind speed. So, and the lowest point here, you can see there's the lowest point. So slightly under the lowest point, we can put a threshold. We call wind stow speed. So only under this threshold, your tracker can do the tracking freely because it's safe if you put the tracker at any angle with like any wind direction. Let's say the wind speed for this is, for example, 16 meters per second, okay? 16 meters per second. And what if the wind speed go above this line? If the wind speed hits 16 meters per second or go above like 17, 18, then the tracker will have to go to a stow position. So on the right-hand side here, that's the right stow position for traditional tracking. So it's right here. So that's like, let's say 30 degree or 40 degree, nose down towards the wing. So wind come from this direction. We call that a -30. So your tracker should be safe as somewhere here. And the wind speed over here, let's say, for example, maybe it's 40 meters per second. So which means this design can safely run at a place where the wind speed should never go above 40 meters per second. Okay, what if we use a large module? If we use a large PV module, you can imagine the size of the plate has become big and the tracker become long. So the entire structure will be kind of fragile. So the result reflects from the wind tunnel test is that they simply drag down this curve. The curve used to be here. Now it's been dragged down a little bit. So it used to be, the wind stow speed used to be 16 meters per second. Now it could be 12 meters per second. So which means it narrowed down the operational wind range of a solar tracker. And still the tracker needs to stow at a very steep angle to get the highest critical wind speed. So if we look at the climate in Thailand, because Thailand is in a tropical area, so like the storm could be a very serious problem, or I could say challenge for solar projects in this area, especially the ground mount projects. And most of the time, the tracker will have to face a strong wind situation. So if we imagine there's a very strong wind blowing towards a steep tilt angle, like a tilt tracker, what could happen? So first, there's something called glapping stability, or you can simply understand that as the little panel will get swaying. That's something easily happened. And the second thing is the wind pressure could be very strong onto a very big panel, a PV panel, and it could damage the solar panel. Even if it doesn't damage the panel, you see, okay, the panel looks fine, but actually the wind is massaging the panel and you will have like the micro cracks on PV cell developed it in the solar panel. So that's the background why we should develop the multi-drive solar tracker. So as you can see that Arctech Solar, we developed our first multi-drive solar tracker in late 2019, which is SkySmart 2, and it has been mature and launched to the market in 2020. And in 2021, we developed a Skyline 2. It's the 1P tracker with multi-drive. So here you can see the innovation on these type of solar trackers. Yeah, not sure I've mentioned that both of them are the first of their type in the market. And Arctech is actually leading this trend of multi-drive trackers. And right here, I have a little model. I'm not sure if you can see this clearly. So this is a Sky Smart 2 tracker. So it's a 2P configuration. And what's on my hand, that is a 1 versus 50 tracker model. And it's just half tracker. So basically, this is the middle point of the tracker. And here should have like a symmetry parts. Yeah. So let's see the secrets behind the tracker. So that's the first or the master drive, the motor. Everything is from here, like the rotational force, and then we have a transmission shaft right here. So this transmission shaft will pass the rotational force to a slave drive right here. So this is like a one wing, and then we have like another wing over here, and it will have the same structure. And let's come back to the presentation. You can see that here is the motor, like the traditional tracker, but it will pass the rotational force to another two slave drive. And once there's like a high wing situation, all these three drives, no matter the master drive or the other two like slave drive, they will play like the lock. They will become the lock. So it's no more like a fixed end here, like a one fixed end here, but you have actually create another two fixed points. So we call that's the reason why we call a multi-fixed points or multi-drive. Yeah, whatever, whichever you want to call that. So the actual cantilever, or we say from fixed to free, is just this short. So because of that, it makes the entire structure very, very stable. And in 2021, we launched the Skyline 2, which is a 1P tracker. So it's like a one row of panel. And the motor is actually on one end. And we deck up the slave drive one by one afterward. And it actually has the same structure as the Sky Smart 2. And sometimes you could see two drives or four drives. That depends on the actual design. But the concept is you always need more drives to keep the tracker stable. Here is the result of the wind tunnel test on multi-drive structure. And as you can see, we used to have a V shape for a traditional tracker, right? The lowest point will be somewhere here. You can see the V shape. I'll just draw it out. The lowest point is here. 0 degrees the worst for stowing, and the highest wing speed is here. But for the multi-drive, we actually flip up the V. It used to be like this, now like this, which means the horizontal stow point will be the best. We could do this when there's a high wind situation. And we also increased our lowest point from here to here. Let's say that is like 20 meters per second. So that would give our tracker more operational wing range. So let's say after 16 meters per second, the traditional tracker needs to get stow somewhere, but the multi-drive tracker can still do the tracking until the wing speed reach 20 meters per second. And with the highest point here, it could go up to, let's say, 70 meters per second. So that's much, much higher than the 40 meters per second, as the example I just mentioned. So this will help to give like more opportunity for this type of tracker to be applied, to be deployed in those high wind area. Okay, sorry. And one more thing is that if we look at the horizontal wing stow position, you can see that this little orange area represent the wing pressure onto the solar panel. And the wing pressure is actually very, very low now, because most of the wing just go past above the panel or under the panel. So in this case, if we go back a little bit, if we check these type of like a disadvantage of traditional tracker, like you might get banded, you might get micro cracks, everything. Now it's free of mind. You won't have that such strong wing pressure onto this panel. Okay. Right. So everything I've just explained, like before, are can be concluded as this logic chain. So with this multi fixed point structure, we are able to reduce the wing speed, the wing pressure onto the solar panel, and therefore you don't need as strong component as before. And in the end, that's a saving from the investment. And next part, I'll explain a little bit more on a positive side effect. We found this in late 2021 with this multi-drive structure. We increased the wing stow speed and we increased the time of tracking. And that is actually increasing the energy yield, or you can say more revenue or benefits. Let's take one example from Thailand. So we did this random case study from urban area, Thailand. We just assume that there is like a 100 megawatt projects being developed right here. So here we are comparing 5 different solar trackers. So they have different stow parameters. So Skyline 2, SkySmart 2, as I just mentioned, they stow at 0 degree, or let's say a horizontal stow position like this. And while other trackers, if they still like apply the traditional structure, they will have to stow at like 30 degree or maybe even 45 degree, like a very steep angle towards the wing. And also among this tracker, they have different stow wing speed. So Skyline 2, SkySmart 2, the multi-drive trackers, they have the stow wing speed over 20 meters per second, while other trackers could be either 14 or 12 if it's like a worse management. So this is the wing speed distribution in that area. So as we can see that, okay, the x-axis represent the wing speed, and the y-axis represent the hours or the time. So we accumulate the time of different wing speed in this chart. So as you can see that the low wing speed will happen more frequently, while the high wing speed maybe less frequently or occasionally. And then if we place the wing speed threshold into this histogram, onto these charts, you will find that with the lower critical wing speed or the lower stow wing speed, there will be more hours for the tracker to get into a stow position. So right here, we can see that for the multi-drive tracker, luckily in this place, there's like a node time, it should go to a stow position. But for other trackers with different, or I mean with the lower critical wing speed, they need to go to a stow position from either like 37 hours or 150 hours over the year, which accounts for from 0.4% to 1.8%. So let's pick one day, for example. I trust everyone should somehow familiar with this kind of charts because we're all doing solar, right? So we pick 17th of February to do this case study. So in 17th of February, if there's nothing happened, everything's perfect, then the solar tracker will follow the blue line, which is an uninterrupted tracking. I said 60 degree, so it's like from 60 degree east to 60 degree west. And I also simulate another 3 curve. If a tracker has to go to a horizontal stow position, so it will be like a fixed tilt for the whole day. So it will be the orange line. And the green line represent a 30 degree east, and the yellow line will represent for a 30 degree west, like this. And you can see the light gray bar, they represent the wing speed of the day. And on that day, you can see that the wing speed is high during the lunchtime, and low on the other time. And one thing needs to mention is that for the entire day of 17th of February, it's a western wind, dominating the whole day. Okay, let's look at Skyline 2 and SkySmart 2 later. So this dashed line represent the wind speed threshold. For Skyline 2, that's 22 meters per second, and for SkySmart 2, it's 20 meters per second. And in that day, none of the wind speed has ever reached that critical wind speed. Oh, sorry, the wind stow speed. Yeah. So both tracker can do the uninterrupted tracking. So the orange area will represent the energy output, and it perfectly matched the blue line, which is mentioned. But if we look at Model A, who has 40 meters per second wind stow speed, then between 11 and 1 p.m., 11 a.m. and 1 p.m., this tracker will has to get to a stow position. That is because during this time, the, during this time, the wind speed has actually surpassed its low wind stow speed. So the tracker will have to do a stow position like this towards west because the wind comes from the west like this. And the problem is, especially in the morning. So let's draw it here. Yeah. If it's in the morning, the sun is off actually right here. So the tracker is actually backwards towards the sun. The sun's right here, but the tracker is facing this direction. So you can see that in the morning time, there's like a big gap, and this gap actually represents the energy loss for a steep stow, like a tracker. And now if we look at Model B, the situation is worse because almost after 9 a.m. in the morning, the entire, almost like the entire day, the tracker has to stow at a 30 degrees towards the west. And the sun is coming from the east to the west. Yeah, but it's like you're missing a lot of energy during the early morning, like the entire morning. Yeah. And it's even worse for Model C. Model C has the same stowing speed as Model B, but it has a steeper, like a stow angle. So that's like it's way back towards the sun when in the morning. So there will be huge energy lost. Yeah. So if we look at the entire year, like a statistic, we will find that Skyline 2, SkySmart 2, or we call the multi-drive solar trackers, very luckily they don't have any like energy lost in these particular site. Therefore, there will be no revenue lost. But if we look at other trackers, if they are like traditional trackers, like single drive trackers with the traditional or like the worse stow parameters, they will have this much energy losses from 200 megawatts to almost 1 gigawatt. And if we translate that into financial loss, here I put 56.5 US dollar per megawatts. It's approximately equivalent to 2,000 Thai bahts per megawatt hour, or maybe 2 Thai bahts per kilowatt hour. And you can find that the annual loss could be ranging from 10,000 US dollar to over 50,000 US dollar. That's a huge amount. And we also create a chart to explain this type of energy losses. So in this particular area, only if your solar tracker has a stow wind speed over 70 meters per second, you will be safe. But if it's under, you will have some like energy losses for sure. Yeah, the steeper angle, the worse. You have like zero degree, like horizontal, it's still fine. But if you do like a 30 degree or 45 degree, it will get much worse. We have also made a lot of like a case study on different on other different sites around the world. If you would like to learn more detail about those case study, you are welcome to download our white paper from this website, or you can just simply like scan the QR code and get this the white paper. So yeah, so everything above will be something on the multi-drive structure. And I would like to talk a little bit more about the 1P tracker Skyline 2. So I think we've talked enough about this. And now I'll be giving you some idea on the pentagonal torque tube design, standardized design, and the modular design. So this is another innovation from Arctech 1P tracker. So we do this pentagonal like torque tube. And the benefit for pentagonal torque tube is, let's draw like a little image here. Yeah. So most of the wing pressure or wing force towards uh, uh, like a torque tube actually coming from here. Yeah. And with this pentagonal torque tube, it has like a much strong capability to cope with this bending force, the bending force. It's because of that, we are able to enlarge the span between the posts. So the post used to be like this narrow. Now I can do a longer post. I'll put it here. If it's like the traditional torque tube, the post will be like much close. But now with a pentagonal, the post can be a bit loose. And that's actually a saving on the post. And if we could reduce the number of posts, we could further reduce the insulation over the post. And therefore, that's the saving from EPC or from the project investment. The next thing is the modular design. So we have made this innovation for especially for the projects with smaller land or undulated land. So previously in solar tracker design, if the tracker is like two string, let's say this one is a two string tracker, and the other one is like a three string tracker, or you could also have like a four string tracker, whatever. Each of them will be an independent design or a special design for the project. Yeah. So every component in this tracker could be very different from this tracker and could be different from the four string tracker. But for modular design, we are actually doing a deck up. So if we design a two string tracker already, and then you say, okay, let's get a three string or four string, you can just simply deck up the same proportional of the same components. Yeah. And this will give you a free of mind of installation, like a challenge and on-site management. Yeah, because sometimes you need to manage like so many different type of posts in on-site. But if it is coming from almost the same component, it will be much easier, and also much easier even at the preliminary layout stage. Next one will be the standardized design. So the standardized design is simply offer our clients a chance to make all the tracker into one type, because there could be external tracker or internal tracker. External tracker are normally a stronger tracker. They are using like a thick material, and internal tracker maybe lighter material and cost saving. But with our Skyline 2 design, we can actually standardize both of them. So that's another free of mind in project management, because you could only have like a one type of tracker on field. So here is another QR code for you to get the video. If you don't mind, I would like to play that video here and use that to end my presentation.
Traditional 1P tracker design. Trackers are designed with different size foundations and varying embedment depths. Along the perimeter of the field, thicker and heavier foundations are required. whereas thinner and lighter foundations are found in the interior of the plant. This is a great way to reduce capex when it comes to tracker design. However, in a world filled with uncertainty, land ownership, construction permits, site conditions are often in conflict with the tight construction schedule. When changes in layout occur, people are facing the risk of overturning the entire layout design and to delay in grid connection, which result in financial grief and loss. Arctech's rigid tracker Skyline 2 with synchronous multi-point drive mechanism now offers a new solution of certainty. The synchronous multi-point drive mechanism technology rigidifies the tracker to the point of enabling 0-degree wind stow mode, hence reducing the difference of wind pressure and post loads between the exterior and interior of the PV plant. By doing so, Skyline 2 enables a new possibility of designing the plant using trackers with identical file configuration, which completely eliminates the risk of full reconstruction when the plant layout changes during construction. Moreover, due to the multiple fixed points that prevent high torque concentration on a single point, it only requires up to 2 different posts within the same tracker footprint. The extra stiff pentagon tube also allows for the fewest posts per megawatt among all 1P trackers. For years, Arctech has been your trustworthy solar partner in achieving the lowest LCOE. The new horizontal single-axis solar tracking system Skyline 2 will empower you with certainty in an uncertain world.
All right, so that's the end of my presentation. Thank you very much. I'll hand it over to Priyanshi.
Thank you so much, sir, for this insightful presentation. So now it's time to begin with our much-awaited panel discussion, which is on latest advancements in solar tracker technologies, Thailand. And to discuss this, we have in our elite panel Mr. Milan Koev from Hexagon Peak, Mr. Yang Guo from Arctech, Mr. Max Jiang from Arctech, Ms. Tess Elbor Napa from Arctech, and Mr. Bancha from Gungul. He will be joining us in a while. And we have Mr. Rasa Harabat from Prime Road Power. I request all the attendees to kindly put their questions in the Q&A box. Our panelists will answer them in the end of the panel discussion. Now I welcome all the panelists on the screen and requesting Milan sir to lead the discussion. Thank you so much. Milan sir, over to you.
Thanks, Priyanshi. Hi, everyone.
Hello.
Hi, Yang. Quite a nice presentation. I guess we're going to have an Arctech panel here.
Thank you very much.
Which is fine. But I guess I will be asking a little bit more questions on how all these technological innovations translate into the actual pocket money for investors. And that's exactly I guess your goal as well, because in your presentation you stated that you are continuously delivering lowest LCOE as compared to other systems. But first, before we go deep there, can we have a quick intro from the other members of your team?
Oh yeah, sure. Yep, I could do this here. So from Arctech, we have Mr. Max Jiang. He's the head of Asian Pacific region. So he take care of all the sales and the customer relationship in Asian Pacific region. And we have Ms. Tess Napa. She's the principal engineer for entire Asian Pacific region. And myself, the product marketing manager here.
Perfect. We have Rasa also on the call joining us. Can you please quickly introduce Prime Road Power as well?
Yeah, hi. Good afternoon, everyone. I'm Rasa, as asset management and project manager from Prime Road Power. So we are regional developer focusing on South Asia and especially in Thailand, Taiwan, and Cambodia and Japan. So we are the developer for solar projects and as well as the EPC for rooftop in Thailand as well. Yeah, nice to meet you guys.
Thanks, Raza. I'll start with the question to you first. How much trackers have you seen in Thailand, really? I mean, there is no much utility scale projects taking place since, I don't know what, 2016, 17, 18? Probably even earlier. In the last 5 years, definitely there is absolutely no traction on this segment. Um, and I'm gonna extend this question on whether in the near future we would start seeing a little bit more utility scale projects in Thailand.
Yes, Milan, thank you for your question. I think previously on the tracker improvement in Thailand, we did see the kind of the tracker technology to be penetrated in the cooperation tool program, which is the last one that we have the PPA release from the government. So in Prime Road ourselves, we do have about 10 megawatts operating at the moment where we're using the tracker, and we do have the acquisition of the operating assets and do repowering using the tracker as well. That the Thailand in the past, but in the future, as you mentioned, Milan, I think the PDP in Thailand just released the pipeline of the utility scale solar coming soon, and alongside the pipeline very solid for solar and wind energy. So the solar, I think, technology driven to minimize the cost for the bidding. The LCOE is very important, and I think technology wise, tracker is an important role to drive LCOE to be competitive in the market as well. We do want the bidding in Cambodia with ADB last couple of years, and that's the technology using the bifacial tracking as well. Okay, that's yes.
Thank you, Russell. Thanks. When you say there is a pipeline of utility scale, how do you estimate this in terms of timing? And what particular policies are those going to be that will be applicable for large scale solar?
Let me check the number. I think the PDP just really okay. I think the PDP just released on they are under the finalization, I believe. So the target is coming out to be the pipeline for renewable energy, definitely solar and floating and solar with battery as well. So but it's still under the finalization stage with ERC to be announced. So I cannot share the exact number for solar, but do have the pipeline around minimum 20 every year from 2000, let's say from 2024. The exact number need to be looking to the documents, but yeah, I think we do see the strong pipeline for renewable energy development in country in Thailand.
Understand. Thank you. And last follow-up question. You mentioned 10 megawatt of operational projects in Thailand that use trackers. And I'm sure you guys have a lot more that have no trackers. Do you have any real-time data on what is the benefits, the financial benefits or the performance benefits of those that use trackers and those without?
Okay, for the one that I mentioned, we have in southern part of Thailand, we don't have the direct comparison though, but the one that we did repowering, we do see the plant performance improvement about around 40%. But on the fact that we do change the fixed tilt to the tracker, and plus changing the PV module as well from the performance lower performance module to be the new one, and including the tracking that can increase the performance or the yield production per the same irradiation by 40%. That makes sense for us. And one concern from the investor perspective is that on the P&L, you may need to look on the asset. And when you take into account of the replacement and the write-off thing on the asset value with regard to the depreciation, you need to take into account all of that, and as well as a full ecosystem. Once you replace the new one, how about the old one that regarding to the ESG theme that we are looking forward to, right? We are economic, social governance. We need to have the ecosystem to be remobilized, reuse the old panel, the old steel, and that is critical for us as well, apart from the financial point of view.
Absolutely, and that I think will be a very nice topic to continue with Arctech, and I'll ask Yang on
Yes.
particularly this. Another line of your presentation mentioned, get some certainty in uncertain times, or not sure how you structured it, but anyway, the certainty that we're talking about is also related to, as Rasa mentioned, the warranties. And yes, I guess from your presentation, it looks like you guys are putting a lot of thought in how to optimize the technology to make it more efficient. But essentially, from the investment perspective, we need to make sure that this technology lasts for a long time, and that also comes with outstanding warranty and after sales support. How do you guys stand in this regard?
Okay. Max, do you want to take this?
No, that's okay. We can take.
Yep.
Go ahead,
okay.
please.
Right. Okay. So for us, we do have like a standard warranty, just like the whole industry. So normally it will be like let's say 5 years for the electrical parts and 10 years for the mechanical parts. But yeah, if you see that the actual design for is actually for the entire like lifetime of the projects, and the minimum design lifetime has to be like 25 years. Yeah. So it's highly related to the corrosion of the steel, like the galvanized steel, and these will have to be like fully customized, or let's say with the requirement of the local environment and like situation, environmental situation. And yes, it could be extendable if you like to have a 30-year, 35-year or above, like a lifetime. This can always be designed and customized without a problem.
That is perfect.
Yeah.
What about after sales support, particularly in Southeast Asia? How quick are you guys in order to solve and fix potential issues?
Yeah, I think I would like Tess or maybe Max to give an answer.
Yeah, now, normally we have a dedicated project management team who is based in China, and also we also have different project management team based in Australia and in India to support all the projects in Southeast Asia. Normally, once we get any feedback from the customer side for projects, that we can um, let's see, identity the problems within 48 hours and give the feedback or give the suggestions to the clients. And also, if there's something happens, then we also will support the customer. Also, will send our engineer to the site to support the projects as well. This is a normal process in Arctech, how we're going to do the after-sale service.
Okay. I guess Rasa raised a point on sustainability. What happens with the trackers after the lifetime of the power project?
Our tracker is designed for or the lifetime of the projects. But after the lifetime, I would say that after 20 or 25 years after operation of the projects, the tracker is still working as same as the module. Now, we give the warranty for projects, but after the warranty period, the tracker is still working. But it requires the additional service. For example, we need to check the status of the tracker or the electrical parts, maybe a years or 2 years every time to make the maintenance much better within the warranty period. This is the things we should say that. Also, we can provide extended warranty or extended spare parts to the projects for the OEM company who can take care or look after all the projects trackers at site.
Okay, fair enough.
Yeah.
I guess
I-
my question was rather whether you guys have any sort of recycling policy in place.
Well, it would not necessarily be the policy from the company itself, but you can see that right now the solar projects are more like a 5-year-old or 10-year-old. I mean, the oldest large solar projects in the world. Yeah, and they're still like 20 or 30 years ago. And I trust that each country would have their own policy and the supply chain to recycle like uh, the disposable like a steel or the like a building materials, just like a building, like a house. Yeah, if you like demolish it, yeah, there will always be such kind of like a policy or the local like a business to run this. But I think that's quite an interest point because we are also kind of researching on this type of like a policy. And yeah, we are thinking actively how can we help or support in this regards.
Understand. Okay,
Yeah.
I guess my next question is a little bit more case studies
Yes.
because I guess at the end of the day, it's always capex versus generation increase. And so we've heard from Rasa that there is a approximately 40% delta for the truckers versus no truckers in southern Thailand.
Yeah.
How do you see this in other regions in Southeast Asia?
Okay. If you don't mind, would you allow me to maybe share my screen here?
Please.
Yeah. So this is a very okay. Sorry. Until they can see that. Can everybody see this? Yeah. So this is like a very, very recent study from my end. It's just trying to compare between different racking system. Yeah. I used to do a lot of work trying to compare different solar trackers, but this time I just try to like do a one step back and check the different racking system. So right here we are comparing the yellow line, which is single axis tracker. The blue line is the fixed tilt with the optimal angle, and the gray line is the seasonal adjustable fixed tilt. And the orange line is the east-west. I don't think that's used commonly in Thailand. So let's just simply focus on the yellow and the blue. So the x-axis represent the latitude. Each dot represent a location, not just in Thailand. I only list Thailand, which is I just assume a place in Pattaya, Thailand. Let's say if we put a solar tracker here at this place, it will have at least 15% energy increase. Yeah, if you compare that with a fixed tilt, which is only 3.6%. So the gap is kind of fixed and large. So with a fixed tilt, it has nothing. It's like you don't get any improvement if you compare that to 0%. 0% is like the horizontal. It's like you put your panels like this way. Yeah, I know it doesn't make sense to do that, but you can see that if you do a little bit tilt, like the best tilt optimum, like a fixed tilt in Thailand, it doesn't do much, like 3.6%. But a solar tracker will guarantee at least 15%. And currently, we have approximately 80 megawatt deployments in Thailand, and we have a case study of 5 megawatts. I was trying to find that one, and then in that particular case, the energy output is 5% better than what we could simulate it from PV Assist. I would rather believe that's the we have like supreme quality or anything, but sometimes it could be the year on year the irradiation difference. Yeah, so I wouldn't surprise if we have like a 40% energy, like a more energy yield, if you compare it with horizontal or fixed tilt. But what I can say that 15% is like the minimum. It's like for sure you will get this much. But if you look at the cost wise, it wouldn't be 15% more. It's just like a slightly like few cents, US cents more than the fixed tilt, and that's it. So if we come back to talk about the LCOE, I remember that's your very first question to me. It's been proven that single access tracker will definitely have the lowest LCOE over everywhere around the world. Yeah, 1T represents single access, 2P represents double access. So the 2T will have like a two access. The reason why it's too expensive is because you need more land and you would need to invest more on the stabilization. Yeah, but 1P, it's been kind of mature. This is like like a one single access, 1T. Yeah, it's like a very mature and proven technology to the market. Thank you, Milan.
Thanks, Yang. It will be really useful to see this case study that you're trying to find. Hopefully, nothing confidential here, but yeah, it will really make things a little bit more interesting. I have another question, which is more about financing, or rather, so-called bankability. Do you see a lot more banks having issuing approvals for trackers used in large-scale solar for applying for financing solutions?
I would say yes, more or less like this, because these days, when you actually want to pick a the equipment supplier, like investors, they always need to get like some finance from any financing institute, like an investment bank or any other commercial bank. Although the banks, they won't do as much auditings or review on the equipment themselves, but they will highly rely on the judgment on the EPC as well. So if the manufacturer is not like let's say big enough or with a good financial health, it will also always be questioned during the investment stage or the project development stage. So let's take Australia, for example. You only see the top 5 solar tracker who can supply to a project over 50 megawatts. Yeah, and only the small company can try sub 5 megawatts projects. Yeah, so I believe this trend will be proliferate. I believe in like emerging markets, like Southeast Asia, Latin America. In the future, we'll see this trend happening. Like the banks, they will start to care more about the financial health of the equipment manufacturers. Yeah, and I think luckily, if you're checking the most recent Bloomberg, Bloomberg New Energy, finance, like the magazine, like the subscription, you will see that Arctech is like one of the top PV company who has like a very good financial performance at the moment. Yeah.
Okay, fair enough. I'm gonna involve a couple of questions from the audience at this stage. There is Chandresh from Sterling and Wilson asking how multi-drive will reduce the microcracking module. Is this somehow related to the wind?
Yes, of
Or,
course. Yeah.
yeah.
Sorry, is that question from the Q&A list, or on the right-hand side, since there are some questions, should we cover those first, or?
No, I just want to cover that and
Yep, no problem.
go through a little bit of technology at the moment.
Okay. Let's put it like a very simple way. I'll bring this a model again to explain. So let's see from this side. Okay. Let's see from this side. So let's imagine this is a traditional solar tracker, right? And if for a traditional solar tracker, if the wing, a strong wing, comes from this way, the tracker will have to stow like this, like towards the wing. If the wing comes from this way, the tracker will have to stow like at this direction, right? So which means each solar panel, I can actually pick up the solar panel from here. There you go. So each like solar panel will have to cope with the wing face to face, right? The wing come from here, it just have to cope with the wing face to face. And the solar panel used to be 2.1, like 2 meter times 1 meter big. Let's assume like this big. And now PV panel are become bigger. They're like this big, like 2.4 times 1.3. But if you look at the data sheets, the actual standard of the solar PV panel, the front wing pressure capability is still 2400 Pascal. So if you distribute, you have like a 2400 Pascal, the same like a pressure onto this, like the different size of like a panel. What could happen? You will actually have more wing pressure, and it's much fragile. It's like a more fragile, and it can easily get like bended. Okay, like I mentioned before, if the wing does not directly destroy your panel, it could still do a bit of massaging on the panel like this. If the panel is facing the wing, you got wing blowing, always like massaging. And can you imagine what could happen to the solar cell in there? Micro cracks, right? And now with a multi-drive tracker, and only with multi-drive tracker, for the first time, we can safely stow the solar tracker at a horizontal stow position like this. So no matter the wing comes from this end or this end, I just do it this way. And only with multi-drive trackers. And I think this is easy to understand. If no matter how big is the panel, as long as it stows at horizontal, the wing just go past above it or under it. So there will be less wing pressure onto the solar panel. And it's a very, very big improvement in terms of coping with the micro cracks. Yeah, I hope that answered the question.
Yeah, that explains, I guess. And I suppose since this is a new product which you just recently launched, there is no much case studies of any heavy storms, super fast winds, whatever. Any data that you have gathered on how the tracker behaves in stormy weather?
I could give you some data. Just give me a little bit time. I'll just find that for you.
Maybe Test Man can also give her inputs on the
Yeah.
same.
Yeah, my background is actually on structural engineering. So I dealt much on the foundation design and also the stiffness of the structures. So things like that. So in terms of innovations, what I could say is Arctech, which is ongoing, doing that kind of trend to improve and to give the most added value to our clients, is we introduced the 2P Sky Smart 2, like the 2P Portrait, and also the recently Skyline 2, which um, Yang has already introduced. So in those systems, um, we have reduced some 30% of the number of piles as compared to the conventional tracking system. So, and we have our own wind laboratory, which we actually study the behavior of the wind. So I'm now, I think, Yang, you're ready to
Yeah,
share.
sure. When you
Thank you,
finish.
definitely.
Okay. Yeah, so here we do have some like numbers to show you. So these were the calculation from the some DAF, like the amplify factors from the wind tunnel test. So wind tunnel test is the start, or you can say it's like the beginning of everything. So here we just comparing our own products. So the left hand side is the SkySmart 2, and the right hand side SkySmart. It's like the traditional 2B tracker, who stowed at 30 degree and under 41 meters per second. Like let's say this is like the strongest wind speed in the region A, Australia region, and you can see that the highest wind pressure onto solar panel is way different. Yeah. So on the left hand side, you can see that the highest number is 1400, slightly over 1400 Pascal. And on the right hand side, it could go over 3000 Pascal. So if we couldn't use, let's say, like an enhanced, say, purling or anything to hold the solar panel, yeah, you will have the chance to get the panel get like damaged or micro cracks. Yeah, but with like 1400 Pascal, that's very, very safe because the best a panel can do is like 2400 Pascal. So I hope this can somehow answer your questions there.
Thank you. Perfect. Rasa, I want to ask how the situation is in other markets. You mentioned Taiwan, Philippines, if I'm not wrong. What do you see there? And I would suppose the further away you go from the equator, the more it makes sense. But essentially, it's also a lot of regulatory complications, particularly so in countries like Vietnam, where trackers do make perfect sense, but there is obstacles in terms of regulations. So can you brief us a bit on what's the situation in other markets that you're active in?
Oh, okay. So just a brief one, we are active in Taiwan and Cambodia. So we are not going deeply into Vietnam, given even the investment term is quite impressive at the moment. But regarding the bankability of the PPA itself and also the curtailment issue, that's why we are not tapping into it at the moment for Vietnam. For what the Taiwan one is very interesting, and we do have a footprint. We have the fleet operation and construction and in a lot of business development in the pipeline, and we do see the growing trend of the Taiwan market. So I haven't seen the tracking much in Taiwan. What we do see opportunity a lot, some suppliers, local suppliers doing the 2P or the 2-axis tracking. But for ourselves, we haven't tried. We haven't got the site with the operating with the tracker yet. For the Cambodia one, that the biggest one that we have in the moment under construction, gonna be COD soon end of this year, around 77 megawatt DC. They are under construction and with the tracker as well. So we do hope the harvestment of the energy yield from that from Cambodia soon. And I think the the opportunity is around the region, though. I mean, the Philippines, as Kun Milan just mentioned, the Indonesia, the Australia itself. So we are exploring to every country that we have the prospect alongside the strategy that we grow as a renewable energy developer. So, but another thing that I mentioned, 40% higher up. That's the whole new refurbishing. So not including the changing from fixed fuel to the tracker. The 40% including that, but also changing all the PV modules to neglect the degradation as well. So replacing the PV module, inverter, and tracker. So that's the combination to drive for the 40% yield production. Yeah, Milan.
Yep, thanks, Rasa. I guess, Yang, then what can be done in Vietnam? I'm sure you're aware of the restriction for the land ratio, and I have particular interest on that question. But I guess just in general, it has been a quite a sizable market, and hopefully it will become such again sooner or later, and hopefully truckers will also play a bigger role there. But what's the situation now?
I think I would love Max to maybe give the response on the
Yes.
Vietnam market. Yeah.
Yes. Vietnam solar market has been quiet for a while since 2020, but now we are already working with some projects in Vietnam. They are already using tracking system. But the problem, as I mentioned to you, is in Vietnam, the one is about policy. The market is still waiting for the PDP-8 policy to be announced from the government to see how strong the support it will have from the central government. And also, we're thinking that once we are discussing with the different clients in Vietnam, they are also worried about the connections. Because in 2020, I remember the total capacity, installation capacity is around 9 gigawatts, including utility scale projects and rooftop projects, which caused a lot of the connection problems for the national grid. That's the reason why the Vietnam government is so, let's say, a little bit conservative to support the solar, because as long as they are release any FIT policy or any policies to support solar, they are worried about the market will be, out of control, total out of control. So these two things make the Vietnam market, let's say, a little bit quiet since 2020. But so far, in the beginning of this year, we have been working with different clients in there for some projects. But I want to say the capacity of the projects will no more than 50 megawatts, because they're trying to see, okay, if reduce the total capacity of the projects, somehow it will make the connection more easier. That's the things we are learning from the market in Vietnam recently. But I want to say, as long as the government announced any policies to support the solar projects, then I want to say Vietnam still is like a gigawatt market for utility projects. And we already see the trend in Vietnam that most of the customers has already shown their interest in tracking system instead of usually they use the fixed structure. They already know the advantage and the benefits what the tracking will bring to us. So I'm very happy to see this kind of the trend in Vietnam, but we are ready to see those clients are ready to pay more premium on the tracking system, but which will, let's say, dramatically reduce the LCOE and make the payback of the projects much better. So this is the things we are learning. And also we are ready to get already some projects, small projects like 10 megawatts or 20 megawatt projects in Vietnam, already tried our tracking system, and they are still under construction. And I would say we will be ready in the market before it's booming. Milan?
Thanks, Max. Yeah. So my question was rather on the policy that we will enable more tracking into the market. But anyway, thanks for that. I want to ask everyone. I guess we have something like 5 minutes until the Q&A session. I want to ask everyone for a few lines on what the future lies. What is there ahead of us, and probably ask a funny question that will be something like, when are we gonna see gigawatt scale floating projects with trackers, which is probably ultra high tech, but why not?
Yeah, can you share some
Yeah.
opinion on the tracker of floating system?
Okay. It's a very interesting topic. Probably that's like it could be useful in Thailand market or maybe Southeast Asian market, because I think there are many like lakes or ponds right there. The floating system these days could be one of the hot topic, but still we still have like a massive land, right? Land area is much bigger than the ponds or lakes. And if you come up with like a gigawatt size projects, I think that will highly depend on the situation of the country, the policy. Eventually, it will come. I believe it will come, because the international community is looking for the carbon neutral. Yeah, it's just a matter of like who's faster, who's just like kind of slower. Yeah, China has invested a lot of like money in getting carbon neutralized technologies, same as Australia. So developed country like Europe, the US and European countries, they are all moving ahead of this. But we see a lot of big opportunity in emerging market like Middle East, like Southeast Asia. Yeah, these places first have like a very good sunshine, because it's close to, it's like the tropical area. And second, it's like it's still like at like kind of low penetration rate. So in next stage, I don't know probably you can tell me like what's the current status for distributed energy, like the rooftop solar. But I believe if the government or the whole society needs to go to like the carbon neutral in the future, no matter they want to do this 100% by 2050, or maybe 2080, yeah, it will definitely happen. And only with the concentrated renewable energy power plant can achieve this. Yeah, no matter solar, wind, or maybe some other kind of renewable energy. Yeah, this will be a long-term process. Thailand, we are seeing it taking off right at the moment. We're not saying like in 1 or 2 years, but we are saying that at this stage, yeah, maybe in just in the short term, it will come up very soon.
Yeah, thanks, Xiang. But also, we are seeing a trend in Thailand. We call this is kind of a repowering program, because back to 7 or 8 years ago, Thailand used to have a very strong solar projects trend in the markets. It was almost like it reached 800, even 1 gigawatt every year. So back to them, the projects was supported by very good FIT. I remember the FIT was around 5 bahts, even 5.6 baht per kilowatts. But back to them, the module price was very high, but the module power is only around 300 or 320 watts. And also they also used fixed structure. So now it is, because the projects are still let's say having the very good FIT. So some of the customers in Thailand, they are intending to repower the projects with very high efficiency module, especially the bifacial module with tracker system. That will increase power generation a lot. I have a data that we did small projects like megawatts, 2 megawatt, 3 megawatt projects in Thailand. This is called also the reconstruction project. the total power generation is around at least 20 to 25% higher than it was. So this is a very good way when they just to reconstruct all the projects but with new technology. But all the return on investment project is still very good. So this is the things we are seeing in Thailand. And also, as Jan mentioned, there's a carbon neutralization program all over the world. I want to see Thailand government is also very interested in this program. I'm already seeing the trend that they are going to um, announce a lot of the policies to support all the solar projects. But in Thailand, I want to say the large scale utility projects will be less, but the small scale ground mounted projects like 10 megawatts to 20 megawatts projects will getting popular in Thailand. Hi, Milan.
Okay. Any thoughts from you, Ressa or Des?
Yes. Yeah. I just would like to add more point if that can be applicable for the future trend on the solar roof and industrial rooftop, whereas we cannot control some of the shading from the building nearby or the some of the the heritage trees where we would like to go green and don't cut it. So I'm not sure whether if next step for the rooftop can be we can add on the solar tracking with backtracking or something that we can use the AI to optimize the shading or even though to optimize the performance. And in the same time, the cost is a key driver for investor point of view as well. So LCOE coming from the capex as one of the key portion. I do see the current, couple of years trend that the steel price, commodity price is higher, but now it's stable and looking forward to be lower in the near future to drive the mounting structure and the high technology mounting structure to be booming up again. And hopefully the supplier gonna provide, as Milan mentioned, to provide a very competitive warranty in the market as well as for the bankability to control the quality to let the investor to be comfort as well as the bank to invest in the projects. Yeah.
From my end, in a point of structural engineering and the innovations in design, as we could say, we could learn at the current state of the world is that if the health sector has the pandemic issue, the climate change has a prevalent impact on engineering the structures, and solar tracking system is not an exemption, and that we experience the impact of this climate change. So solar tracking companies will never stop innovating, like we started it already by providing the multi-drive, multi-fixed points to account this, to adjust with the changing or the climate changes. So in terms of the structure adapting to this kind of change, we could expect failures because what happened is in terms of engineering design, when the factors of safety are exceeded because of these extraordinary natural occurrences, then the structures and the foundation has to be designed accordingly. But the problem is um, the design codes of most in most countries are not yet adaptive to this kind of change. As an example is the flood. Some of the solar sites or even the biggest structures has been inundated by flood, and it's because of this climate change. So so I think there are initiatives already from different countries to um, make some adjustments or articulations um, to design parameters uh, to to that is adaptive to the climate change for the near future. So rising water table is rising. The soil conditions are being affected by these natural um, occurrences. And so all structures and the technology and engineering has to innovate and to adapt to this kind of ongoing change of the environment.
Okay, thanks, Tess, and thanks, everyone. I would go through a couple of questions that we have from the audience.
Yep.
Hassam, who is from HR background, is asking what type of solar panel we recommend, and I guess Young to confirm, but I don't think there is any difference in terms of solar panel used. Plus, we don't want to make advertising here, so I guess all kind of panels are useful
Yep.
for truckers. Rolly from Trina Investment is asking what is the maximum wind speed that solar trackers can handle, and this was partly answered, but I will let Yang elaborate on that. And the subsequent question is Philippines, particularly where there is hurricanes and so on with up to 90 meters per second. So yeah, up to you. Yeah.
Right. Okay, I'll just give my input, and maybe Tess could help me somehow. So first, like up to what max wing speed can a solar tracker handle? I don't know whether this question is for all solar trackers or is it just particularly for the multi-drive solar trackers. But I would like to answer it in this way: different type of tracker, uh, even the same type of tracker, they could have like a very different design for particular projects. But let's just see what's the highest like number we can reach, right? Let's say multi-drive tracker, they have the capability to reach, let's say, approximately 70 meters per second. Yeah, I'm not 100% sure whether this number is correct, but I would say around that level. While traditional tracker, according to our understanding, or the wind tunnel test, let's say, for example, will be somewhere around like 40 something to 50 meters. That's pretty much like the the best they can do. And this is the question I would say also related to the Philippine situation, which is like a 90 meters per second.
Yeah.
I'll have to say that's something that's somewhere everyone is trying to reach. That's like the Kimulama, the Everest uh, for the solar tracker industry. So far, I think it's also very challenging for fixed tilt, even under that kind of a wing speed at this point of time. Yeah,
Yeah, that
Great.
is.
yeah.
Yeah, in
Tess.
the
Yes.
Philippines, being the cyclonic country in the Southeast Asia, you cannot really accommodate that speed at the moment. And Arctech, so for our 2P system and 1P portrait, the wind speed it can design is 70 meters per second. So, like, it's a region C on that speed. It's a size cyclonic, but not 90 meters per second. And so far on the ongoing projects and solar system in the Philippines, the fixed one is the most common.
Yeah.
Thanks, Tess. Last question is what is the maximum length per rack for the multi-point drive tracker?
Okay. Yep. Keep this number in mind. If you use the Arctech Skyline 2, the Skyline 2, the longest we can reach is 130 meter, and if it's Sky Smart 2, that's 95 meter. But still, that will come back to your actual design criteria. Okay. Then that's yeah. Just remember those two numbers, which are the max we can do.
Thanks, Yang. And back to Priyanshi. I guess we're done here.
I would like to thank everyone. Thank you so much, all our esteemed panelists, for this wonderful session. And very special thanks to Milan sir for moderating the session so well. So I hope the audience had a lot to take away from the panel discussion. Thank you so much, everyone. Till then, bye from our end and take care. Thank you.
All right. Thank you. Thank you, Priyanshi.
Thank
Thank you,
you.
Milan. Thank you, everyone.
Thank you,
Thank you,
Milan.
everyone.
Thank you, host. Thank you.